Hi everyone, I am Muhammad Murtaza and we are going to study limits today. Okay. First of all, let us discuss some basic terms. This sign we understand, equality. Say x is equal to 1. So when x is exactly equal to 1, we write like this. Now x arrow 1, what we mean by this symbol? We read this x approaches 1, x tends to 1. What we mean by this? Before that, we should understand x tends to 1 plus and x tends to 1 minus. Okay. When x is exactly equal to 1, we write x equal to 1. When we write x tends to 1 or x approaches to 1, what we mean by this? So it contains these two terms, x tending to 1 plus and x tending to 1 minus. When x approaches 1 from right, means like this, x is 1 here. When x tends to or x approaches to 1 from right, here 1 plus means what? X is very close to 1 but is not equal to 1. It is slightly more than 1. So like this, x approaches 1 from right, means x is very close to 1 but it is not equal to 1. It is something like 1.000001, so slightly more than 1. When we write like this, x tends to 1 minus, what we mean? Here it is 1 and x is approaching 1 from left. So like this, x is very close to 1 but not equal to 1. It is slightly less than 1, means x is like 0.9999 something, and here x is slightly more than 1, so it is 1.0001 like that. Now what about this x tending to what we mean by this? This contains these two together, means x tends to 1 or x approaches 1, means x approaches 1 from right. Okay, x tends to 1 plus, x tends to 1 from right, x tends to 1 minus, x approaches 1 from left. So when we say x tends to 1 or x approaches 1, it includes both these, x approaches 1 from right and x approaches 1 from left. Okay, so that we got, that is the basic terms. Now when x is exactly equal to 1, what is the value of the function? That is called functional value. So means when x is equal to 1, what is the value of the function? When x equal to 1, fx is 10, means f of 1 is equal to 10. When x is exactly equal to 1, fx is 10. That we got it. That is called functional value. And this is called functional value. And today we are going to discuss limits. Okay, so that is limiting value. So we have to find out this limit. Limit x approaches 1 fx. This is what we have to find out. X approaching 1 fx. What is this value? Or x approaches 10, 20, 30, whatever. What is the value? That is called limiting value. So x approaches 1, then to whatever value fx approaches, that is called the limiting value. So this limiting value we are going to find out. But here the question arises whether x approaches from right or from left. Okay, so here nothing is written 1 plus or 1 minus, nothing as such. So this is like x tends to 1. It includes both these, slightly more than 1 or slightly less than 1. So x is very close to 1 but slightly more than 1, that is x approaches 1 from right and x approaches 1 from left. Now we will have to find out, to evaluate this limit, we will have to find out this limit, x approaching 1 from right, means when x is not equal to 1, it is slightly more than 1, then to whatever value fx approaches, that is called right hand limit, that we should find out first. So limit x tends to 1 plus fx, that is equal to limit x tends to, from this example, fx equal to this, it's less than 1 this function, more than 1 this function, equal to 1 10. So from this example, limit extending to 1 plus fx is equal to limit extending to 1 plus x is more than 1, then this is the function. So we will have to write 2x plus 3. 2x plus 3. Now x is very close to 1 but slightly more than 1. Then this fx, that is 2x plus 3, approaches to whatever value. This is 2 into 1 plus 3 means 2 plus 3, that is 5. So 2 into 1 plus 3, that is equal to 5. So this is our right hand limit. This is called right hand limit. So when x approaches 1 from right, means x is not equal to 1 but it is slightly more than 1, like this. X approaches 1 from right, then to whatever value fx approaches, that is called the right hand limit, that we find, that is 5 here. For this example it is 5. Now we will have to find out left hand limit. Limit x tending to 1 minus fx. So when x is not equal to 1 but it is slightly less than 1, to whatever value fx approaches, that is called left hand limit. So when x is less than 1, what we have? X square plus 4. So we should write limit x tending to 1 minus fx means x square plus 4. Now this limit is equal to what? X is very very close to 1 but slightly less than 1. To whatever value this function approaches, put 1, what do you get? 1 square plus 4, that is 5. 1 plus 4, so again you get 5. So what you observe, right hand limit is 5, left hand limit is 5, both limits exist and they are equal. So we say that this limit exists and it is equal to 5. So this limit extending to 1 fx exists only when both these right hand limit and left hand limit exist and are equal. Here in this example we have found out our right hand limit is 5 and left hand limit is 5. So this limit is equal to 5. Let us take another example. Fx is equal to mod x divided by x. For this function, here this is defined when x is not equal to 0. Suppose we have to find out limit extending to 0 fx. This is we have to find out. Then we need to find out the left hand limit and the right hand limit. These two limits we have to find out. So this is equal to what? Mod x divided by x. Now when x is slightly less than 0, mod x is equal to minus x. So we have to put minus x divided by x. And this gives us minus 1. So this left hand limit is minus 1. And here x tending to 0 plus, this is equal to mod x divided by x. When x is slightly more than 0, mod x is equal to x. So what we have? X divided by x. So when x is positive, mod x is equal to x. So we have x divided by x, which is equal to 1. So right hand limit is 1, left hand limit is minus 1. The two are not equal. As the left hand limit and right hand limit are not equal, we say that this limit does not exist. About this limit, what we will say? The limit does not exist. So for the existence of the limit, left hand limit and right hand limit both should exist and should be equal. In this example, they are not equal. So we say that limit does not exist. Okay, so from the examples, what we have observed about the existence of a limit. Limit of a function at a point x equal to alpha exists if the left hand limit and the right hand limit both exist and are equal. So limit extending to alpha minus fx and limit extending to alpha plus fx. Both limits exist and are equal. Then we say that this limit exists. So limit extending to alpha fx, this limit exists only when left hand limit and right hand limit both exist and are equal. Let us conclude now. Limit extends to alpha fx exists only when left hand limit and right hand limit both exist and are equal. This limit does not depend on the functional value f alpha, means when x is exactly equal to alpha, whatever is the value of the function. We are not concerned with this whenever we have to find out this limiting value. It is like if you have to determine the behavior of a person, we are not concerned with whatever the person himself says about himself. We will have to take the opinion of the neighbors. So whatever his left neighbor says, whatever his right neighbor says, if both the opinions are the same, then that is the opinion made about the person. Here it is like that. Left hand limit, opinion of the left neighbor, right hand limit, opinion of the right neighbor. If both are the same, then behavior of the person is determined, means limit of the function exists at that point. We are not concerned with the functional value, means what? We are not concerned with the opinion of the person about himself.